Name is Neluja Ashley Hope, and here I'm going through my code that was given in regards to linked lists with functions that we were supposed to implement. The first function was create node that took an argument number, which we're using to create a new node using given data. The first thing I did was determine the size of the node so as to know how much memory space would be needed to store this node, and then using the malloc keyword I assigned it to I allocated it to memory. Then I catered for the case in which the assignment to memory fails, in which case the pointer new node that I assigned to the address of this node that had been created, in case that pointer pointed to null, then an error message would appear and the process would be stopped. In another case, in case the memory allocation was successful, then the pointer that is reassigned to number, and it's updated to take up the argument num, and the pointer pointing to the next value would point to null, because, well, at that point it would be the first value, so it would have nothing else to point to. The next function was a print list function. This function prints all nodes in a list. So we started with, printing a square bracket, because in C, when we try to print a list, it won't come out with the square bracket, so we had to print them ourselves as a character. And then we assign a pointer called current to the head value in the list. Then to print this head value, I'll use a printf function and a format specifier, and then update our pointer to point to the data, in this case, which is number, and the head will be printed. Then the current pointer is then updated to point to the next value. We use this to transverse through the list, and if our current pointer is not equal to null, then we print a comma as a character using the printf function, and another value in the list will be printed. When the transversing is done, we again use the printf function to print a square bracket so that we can enclose our data. The next function was to append a value to the end of the list. In this case, we create a new node using a function create node, which, as we saw, will allocate this node to memory and initialize its value with the given num, the argument num. Then first we start by creating a new node using the create node function that is designed to allocate the node we create to memory. Then if we check if the head of the linked list is equal to null, and if it is, then the function assigns a newly created node to the head of the list, making it the first node, and then it returns. Then we initialize a pointer called current to the head of the list, and then we start a while loop. We check if the current pointer pointing to the next value is equal to or not equal to null, and if it's not, then we update the current pointer to point to the next value, and that will transverse the list until transfers the list until we reach the last value, and then after reaching the last value, the current pointer is updated. The current pointer pointing to the next value is updated and equated to the new node, meaning that the value will be inserted at the end. The next function required us to add a value at the beginning of the list, which was prepend. First we started with using the create node function to create this node so that it's allocated to memory, and then the new node. First we created a new node using the create node function that we started with, and then that new create node will allocate this new node we're creating to memory, and then we assign a pointer new node to this node that we have created. Then we update the pointer pointing to the next value to head, and then the new node that we have created is equated to the head. In other words, it will assign the new node to the head as the head of the linked list. Then the next function was delete by key. This function aims to delete a node with a specified key from the linked list. First we assigned a pointer current to the head and another pointer previous, which in this case has been written in short form, prev to now. Then we check if the key is in the head using the if statement. We check and see if our current pointer is not equal to now, and if it's not, then the current number and the current, so we assign the pointer to point to the data in this node, in this case the number. If the number is equal to the key specified in the function, then if it is, then we use the keyword free and current. We use the keyword free and current, which is the variable name for our pointer, to free the memory of the head. If it's not in the head, then we search for the key in the rest of the list. In this case, we use a while loop. We check if our current pointer is not equal to now, and the data it's pointing to is not equal to the key that we specified. Then we'll update our pointer that we at first initialized to now to current, and then we transfer the list. After this, we transfer the list. Then we cater for the option where the key isn't in the list, but if it is, so if it's not, then an error message will appear. But if it is, then if it's found in the rest of the list, then the memory of the node with the key is freed using the free function. Then we had the delete by value. First, for starters, we checked if the value was in the head. Then we initialized our pointers current and previous, and then we check if the value to be deleted is in the head list, and then if it is, then we update the head to the next node and free the memory of the current head. Then if it's not in the head, we check. Then after checking, we first check if it's in the rest of the list. If the value is not in the list, then an error message shall be displayed. But if it is, then we update the pointers to skip the node with the value, and then we free memory of the value. Then the next function was to insert after key. This would allow us to insert a value after a specified key. First we check if the key is in the head, and then if the key is in the head, we create a new node with the specified value. We link the new node to the rest of the list and update the node's next pointer. Then if it's not in the head, we search for the key in the rest of the list. We set a loop to transverse the list until either the key is found or the end of the list is reached, and then we cater for the situation where the key is not in the list. And then if it is found, then we create a new node with the specified value. We link the new node to the rest of the list after the node with the key. And then we had the insert value function, which checks, first we check again for the value in the head. Then if the value is at the head, we create a new node with a specified value. We link the new node to the rest of it. Basically, this is the same as insert after a key. It's just that in this case we're using the value. And then we had the function that was supposed to re-implement using the switch keyword. At the start of this function, we see declaration statements where a pointer to the head is declared, a pointer to the head of a linked list is declared, an initial is set to now, and variables choice and data to store user input for menu choices and data values. Then we see a while loop. This is called a menu loop. It creates an infinite loop to repeatedly display the menu until the user chooses exit. It has menu options, which you can see here: linked lists, print list, append, prepend, scan here to scan the user's choice. Then we see the switch keyword coming in, and it takes the argument choice that we declared at the start. It's used to execute different actions based on the user's menu choice. So depending on what the user chooses, if they pick one, then then a linked list, the head of a linked list will be printed. If they choose two, then they can enter. Then they'll be. If they choose option 2, then they'll be prompted to enter data, and then the data they enter would be appended to the head of the linked list. Yeah, basically that's it.